So, number 14. Hopefully you guys were in radian mode, or else it would not have worked out very well. You had to keep an eye on what the type of angle was that was put inside your trig function. Since there was no degree mark, radian mode, and there we go. Number 24, you were supposed to set the slope equal to the tangent, tangent inverse, except that was a negative. That was digging a hole. We don't want to dig a hole. There's a life lesson in that. Anyway, we don't want to dig a hole, right? We want to go ahead and look up to the mountain like Chris was saying yesterday, I said the day before. They added pi to get radians, but you could have been in degree mode and added 180 to get to 142.1, yeah? Yes. Cool. Number 28, that one you had to work a little bit for it, right? You had to use your y2 minus y1 over x2 minus x1. You had to go ahead and solve for the slope first. Hey, square root of 3. I lost the song. Square root of 3 over 3, 1 square root of 3. Square root of 3, that was a lower version too. That would be a 60 degree. But the problem is that's a negative. Ooh, negative 60. No, look up to the mountain. Add 180. 120. You could have plugged into your calculator and gotten 120 as well. 52. Was this an angle between? Check your m's. If you rearranged incorrectly, this would be horribly wrong. So check your m's. As long as your m's are correct, you rearranged correctly, then you could plug into your formula. And technically, didn't I say yesterday you could just plug and chug this whole thing in all at once? Yes. Just don't forget to make absolute value, okay? So in this one, had to do tangent inverse. You end up with either 61.9 degrees or 1.0808 radians. Well, that's the last one. Thanks, guys. Any other evens that came up last night or odds? Yeah. Yeah. There you go. 24, they gave you the slopes, then set equal to tangent, tangent inverse of the slope. Whatever mode you're in, if you're in radians, add pi. If you're in degrees, add 180. Does that make sense, AJ? It's right there at the very top. All right, any other questions? You're okay? Okay. So on the easiness scale, how was last night's homework? Is 5 really easy? Oh, easiness scale. Sorry, that was just, was it pretty easy? Yes. Okay, it was pretty easy. I didn't even give you a number range. I apologize. You're all like, I don't, Okay, here we go. 10.2, a little bit harder. A little bit harder, but here's my advice in 10.2 and 10.3 and 10.4. Because in 10.2 we talk about parabolas, so we're starting to get curvy because lines are just linear. We're starting to get into the curved portion, which are the slices through the double naped cones, the slices that hit the curved edges. Parabolas are the first curvy ones we'll see. Ellipses are going to be the second curvy ones, and then hyperbolas are going to be the third curvy ones. Guys, for every single section, it's going to be crazy intense as far as there's going to be some sort of page with all sorts of junk that you could memorize. For parabolas, this would be it. There's going to be a page with all sorts of junk that you could memorize. And for some of you, your brains will do better if you do memorize it. But for others of you, if you could get the feel for how the shape works and the patterns of how it works, you might not need to memorize this whole page. So that's what I'm going to teach. That's what I'm going to show. These pages are in the book where it summarizes like all the different possible ways of working with the parabola. But let's see if we can get a feel for what's going on, okay? So I'm going to go ahead and zoom in on the original shape up here above. I'm going to zoom in on this guy. So this guy, one example of a parabola, just one example. The vertex is not at the origin on this example. It's way up here somewhere. It's showing you these two new pieces, the focus, which we talked about yesterday, the light bulb and the flashlight. The focus is going to be a point. Just think, if you you're focusing in on a point. Focus is going to be a point, and it's going to be directly above the vertex. Well, it's going to be directly inside the concavity from the vertex on the axis of symmetry, which means it could be above, but what if I'm facing this way? Where's my focus? To the right. Good. How about this way? Where's my focus? To the left. How about this way? Good. And wherever the focus is, the directrix is the other direction. And the directrix, think direction, it's going to be a line. I guess direction doesn't really help, but that's okay. I tried. Directrix. directed line segment? I don't know. So focus is a point, directrix is not. Directrix is going to be a line. It's going to be a line that's perpendicular to the axis of symmetry, and it's going to be the other direction. So, for instance, what direction is the directrix? Say that 10 times fast. To the left. What direction is the directrix?
Right.
Directrix. Yeah. So if you know where the focus is, it's inside the flashlight. It's the light bulb. It's inside the flashlight. Directrix is the other way. And guess what? The distance to the focus and to the directrix will both be found by the letter P. Did you guys see how there's a P in both of these equations?
Yes.
Now, the old standard with completing the square and all that jazz had an A. But the old version also did not have a 4. And the rearrangement was a bit different than what you see here. So we've seen parabolas before, but when we saw parabolas before, usually y was by itself, or something like in these ones, x was by itself. The y squared, or the x squared part was always over on this side, but what do you notice about these standard forms? Where's the squared part? That side. So we're going to have to kind of rearrange how we think about these. Whenever I start a problem for a parabola, I am going to figure out the standard form I'm going to use first. I'm going to write that standard form, then I'm going to think about, okay, how do I plug in, or how do I get there, or how do I use my clues? But I'm always going to start by writing the standard form and then saying, okay, now how do I use it? But in this standard form, there's the h that we know is the x of the vertex, the k that we know is the y of the vertex, just from review. But there's also this little p guy, and he's going to be the distance from the vertex to the directrix. But guess what? It's nice because he's also the distance from the vertex to the focus. It's the same measurement. Just the directrix is going to go the opposite way of the focus. Depending on how my parabola is, well, it could be different ways. As we just went through, sometimes the focus is to the right or to the left or above or below. Depends on the orientation of the parabola. And so that's what brings us down to these formulas. Because in these formulas, if you guys notice, one of them talks about a vertical axis of symmetry. One of them talks about a horizontal axis of symmetry. One of them talks about a vertical axis. One of them talks about a horizontal axis. Now, a vertical axis, that's going to be an example like you see up above with the parabola being facing up or oriented and facing down. The vertex, we're going to have that HK that we've been talking about for a while. The focus, since it's going to go up, well, if it's headed up, if the concavity is up, this is going to be a positive number like we saw yesterday with orientations, a positive number, which means that P is going to be a positive number, which means that in order to find the focus, we need a formula for that. So in order to find the focus, we're going to actually take the same x value, h, because the x stays the same to get up there. X doesn't change. What changes is the y value, so the k is going to need to add p. I'm going to write that right here. If the directrix for a vertical axis subtracts p, the focus is going to add it. So what one does, the other one does it oppositely. So for a vertical axis, and this is our vertical axis example. It's vertically oriented. For our vertical axis, our directrix is going to take the y value and subtract p because I'm going to have to go down to the directrix, and the focus is going to add p. I'm going to go up. But the directrix is going to be an equation of a line, whereas the focus is going to be a point. The directrix is going to be an equation of a line, y equals k minus p, whereas the focus is going to be a point. Okay, now let's move on to the other guy. What if we have a horizontal axis example? What if we have one that's facing the right? You guys already told me, just see if you remember. Well, hold on, pause. Vertex, sorry. Vertex, he's still going to be HK. Where's the focus for this guy? To the focus? Where would the light bulb be? Inside the flashlight, right? Okay, so the light bulb, here's the focus to the right. Now I'm moving horizontally. I'm not changing the y values, I'm changing the x values. So I'm going to go ahead for my focus. I'm going to keep the y value the same, and I'm going to add p. This would be a positive coefficient again, so p would be positive. I'm going to add p to get to the focus. So all that changes is where you're putting the addition. Vertically oriented, you're adding to the y's. Or you're subtracting from the y's for the directrix. Horizontally oriented, instead of adding to the y's, you're adding to the x's instead. Whether you're doing the focus, which is the point, or whether you're trying to do the directrix, which is going to be a line again, but this time, since it's an up and down line, now I'm going to have x. And instead of adding p, I have to go the other direction, so I'm going to subtract. So here's what we need to play with. We need to play with how do we find p, how do we get the equations to look like this so we can find p, and then how do we go ahead and take an equation and make a graph, or take a graph, take clues, and make an equation. Kind of like, well, I guess in last section you guys weren't really going back and forth so much. You were kind of just using formulas. It's kind of cold. Turning it down. Turning it up, technically. You were kind of just using formulas. But here, we're going to have to actually be graphing or taking graphs and trying to find clues. So either getting equations or using equations. So to that end, let's go ahead and try this one. My hint, which I think is a very, 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 very good one. My hint with all of these, you wouldn't understand this one unless you read the question in the book, so I'm adding a quick clue in there. My hint is graph. Most of us are visual. Doesn't mean maybe we learn visually, but at least we understand a little better if we can look at the visual of what's going on. So my hint in any one of these problems is to graph what they give you. So in this one, they haven't given you an equation. You're supposed to find an equation. I told you the first thing I almost always do is figure out which standard form, but I don't even do that until I visualize the clues. So what have they told me? Good. The focus is 2, 0. So we can graph that point. The vertex is going to be at the origin. Good. The directrix would be over here. What's the only way the parabola can be facing to make all of that true? It has to be going to the right. So now if the parabola is going to the right, now it's time for my brain to figure out, okay, what kind of standard form am I using? Now guys, I see some different composition books from other classes that are being written in, because you don't need paragraphs for my book, my class. I see some worksheets that are being worked on. Let's go ahead and focus back in on Precalc, because that's kind of why we're here right now in this period. So let's transition. Okay, look at your basic graphs. Look at the page before or the illustration up above. Which standard form would go along with facing right? Vertical axis or horizontal axis? Horizontal, because look at the axis of symmetry. Look at the axis of symmetry. So looking back at our clues, just in case you need to see this in order to be able to understand it. A vertical axis will be an up-down one. A horizontal axis will be a right-left one. So I'm going to use this standard form. So go ahead and write this standard form down. Let's start with that. Y minus k, quantity squared, equals 4p. You guys finish off. You have it right there. Okay, who can I plug in? Good, the x and y of the vertex, because that's the hk. So I can plug in y minus 0 equals 4 times, okay, do you see how I just plugged in the vertex of 0, 0? So what else do I need? The p. And what did we talk about with p? He's the distance. Good. He's the distance between the vertex and the directrix and the focus. Now, p can technically be a positive or a negative. So p also determines which way my parabola is facing. So one way to think about it is, well, the distance is 2. It's like the absolute value of p. The distance is 2. And the parabola is facing to the So it's facing what kinds of numbers? Positive. Oh, cool, it's positive too. That'll always work. That'll always work. What's the distance? 2. Which way is my parabola facing? Positive. Cool, positive 2. The other way of thinking about it is you could always make P the directed distance to the focus. Always to the focus. Because if you think about it, to get from the vertex to the focus, you had to go positive 2. If this parabola was switched around, you would be going negative 2 to get to the focus. You can either think of P is the, or for P, you need to focus on the point, you need to point to the focus, get to the focus. Or you can always just think of what's the distance between the focus and or the directrix. It's the same thing. What's the distance? And then go ahead and think, which way is my parabola facing? We could stop there, but I mean, y minus 0, isn't that just y squared? Then 2 times 4, well, that's just 8, and then x minus... Now, technically, there is another way of writing this. But the nice thing is for our purposes, it's totally fine to stop there. Just simplify, simplify, done. But you could have also written it x equals 1/8 y squared. That's how you might see it if it was like an inverse problem, trying to find the inverse of something and the x and y get switched. That's how you might have seen it. But it's totally fine to stop with the original version of it. Michael? If you needed to get y by itself, but since we're trying to write the graph of the entire parabola, not really focusing on needing to make it a function from last semester, just I want the parabola, we'll keep it with the squared. Does that make sense? But yeah, we could have also, that's actually a good point. Let me write that. We could have also written it as y equals, just careful, it would have been a plus or minus, right? We would have needed both. You would have needed the top branch and the bottom. Guys, number 21 is a brand new problem. Technically, you were supposed to steal the clue of the vertex at the origin. That's why I wrote it again. So it's a brand new problem. This time, the directrix is at y equals 1. And the vertex is at the origin. Let me give you a second. Can you guys try to do what I did? Graph it and see if you can figure out, does the parabola, to make that true, those two clues, y equals 1 is the directrix, vertex of the origin, would the parabola have to go up, have to go down, have to go right, have to go left? Just see if you can see it. And just a few of you might try to mentally visualize it, but for most of us, actually drawing it will be so much easier on our brains if we're just willing to reject laziness. Feel free to collaborate in your groups. I totally don't mind. But if you can graph and you can see which one, then pick a form and try to plug into it, just like we did. Remember, directrix is a line. Yeah. Once you get the picture, see if you can do the formula, and then try to plug into the formula. I'm seeing how far you can go. Okay, check in with your groups. Some of your groups haven't really checked in. Check on each other. Be like, hey, nothing else. Give an encouraging smile, even if you don't know what to do. Leo, have you checked in with your group, bud? Check check in with your group. See how far they've gotten on the example. See if they can help you or you can help them. Bless you. All right, my turn. I can play? Okay. Trying to make it so I can pass these back fast when the time comes. Where's Josh Keck? Okay. So, hopefully you guys remember that the directrix was the line part, right? When you went to go graph the line part, y equals 1, hopefully you remembered was a horizontal line following the tick mark on the y equals 1, y axis, right? There we go. Then vertex at the origin. Hopefully you were like, the only way this parabola can go, because parabolas never intersect the directrix. They can't, because they always go the opposite direction. You guys figure out it was down? Okay, so then if you figured out it was down, hopefully you looked at your little clue page and figured out you didn't want this one. You wanted this one. Good. Hopefully when you went to go plug it in, you were like, well, vertex is still at the origin. That's easy. Now, how'd you think about P? Distance of 1. You didn't even have the focus, but the directrix was enough. You could have found the focus if you wanted. Distance is 1, but why is the P not 1? Because it's going down. So you needed the 1 with a negative. Did you get it all? Yes. So then you end up with x minus 0 is x squared equals negative 4y. This is technically right, but as Michael was saying earlier, you could get y by itself, and this one's a lot easier to get y by itself. So you could get y by itself by dividing by negative 4, which is the way we would normally have seen this guy. I'm going to put little parentheses. That's totally fine, and it's totally right. But it's also okay to leave it x squared equals negative 4y, because that way you can find the p if you need to. Okay, so with that, guys, could we memorize this whole page about every possible combination for every possible parabola? Yeah, but maybe we can just kind of get a feel for the clues. Okay, so let's try this guy. Ooh, try again. Stay awake, Leo. Try again. I'll have to make everybody cold again to wake you up. It's kind of nice and toasty. It was cold, now it's toasty. All right, graph both clues and then see if you can figure it out. They did not give you the vertex. Ooh. Okay, we'll see if that turns it on. A couple more seconds. Remember, the focus is the point. The directrix is a line. The focus is the point, and the directrix is the line. on the area. All right, I'm gonna start playing with the clues. What's the only direction the parabola can be facing? Good. Has to be facing the right. So hopefully you guys then figured out, okay, to the right, that needs to be the y minus k. See how I'm also helping you review the formulas? If you have to write them, A, you have something to plug into, and B, you're studying them at the same time. Stink though. They didn't give us the vertex. They gave you enough information because where must the vertex be between the focus and the directrix? In the middle. And what's the middle if you go 2 and 2? It's going to have to be right here. Right? So you can go ahead and plug in y minus 2 equals 4. Hey, just by finding the vertex, didn't we also figure out the distance? Because it's 2, and then, wait, positive or negative? Because I'm facing to the... Right. Good. So that's going to be the positive direction. So therefore, positive 2. So, and Michael, here's a reason why if we don't have to, we might not go doing the whole plus or minus square root thing. It's possible. It'll just get really messy. Jaden. You choose the formulas based on the direction of the parabola. So since my parabola is going right, left, think of it this way. The parabola you're most used to is y equals x squared, right? So the up-down will always go with the x being squared. So I'm going to use the other one, the y being squared, with the right-left ones. So the right-left ones always needs the y being squared, whereas for the up-down ones, like the last example, we were able to use, with the x being squared. All right, let me have you guys copy down this page as I pass back both your Chapter 9B quizzes and your Chapter 9A test. I'm okay with you guys, in essence, kind of putting the two together to make a Chapter 9 corrections. Chapter 9 corrections kind of on both. I'll probably end up giving you like the 9A points, 10 out of 10, 9B points, 10 out of 10, because some of your grades in the portfolio category, you've been missing some corrections. It'll help better to have it be 2 assignments. But you can think of it as one big old correction. Remember that one of them was 75 points and the other one was 25 points? If you want to try to think about kind of how it's going to add to your grade, you can actually add the 2 points together out of 100 and you'll see what your percentage was on all of Chapter 9. Or you can divide in your calculators to see what percentage you got on each of the individual assessments. Because the one scores out of 20. Oh, I meant to make it out of 25. Never mind, don't add your 2 scores together. That'll be very sad because 20 and 75 add up to 95. When I put them into your grades, I'll make sure it's worth 25 points because some of you did really well on the quizzes and I want that to be able to help. Never mind, don't do the whole adding thing. That's silly. Go ahead, Michael.
So what if they only give you a vertex?
It wouldn't be enough information. Yeah, it's a great question. It just wouldn't be enough information. Oh, I'm sorry, Jacob. Corrections will get us some points back on Chapter 9, kiddos, because it was a little rough for some of you, depending on how you studied, etc. Doesn't have to be done on Monday, but I'm trying to give it to you before the weekend in case you do have some time to start working on it, and you guys have been asking. So I finally got them all finished last night and this morning. Thank you for your patience during this AP season. But good news is, for some of you, these ones didn't get in on the last grading period. So maybe that was a random blessing. Joel, I found one of your old tests. No wonder you were missing those corrections. So if you get them in, I'll get you credit on it. You must have been absent the day we passed them back. Yeah, Chris. You could add 5 points. Yeah, that would be one way of doing it. Add 5 points to the quiz and then add that to the test. Yeah, 5 points were missing on the scores. But it'd be add 5 points out of 25. Does that make sense? Like it doesn't just add bonus. Okay. Curie. Perfect. It probably was from when you were absent or made up the test and we just didn't get it written down. Thanks, bud.
No, the front, the back. Look at the very back.
Hey guys, listen up real quick. Today was a little crazy as far as meetings before school, and so the backboard hasn't been updated. This one type of problem we didn't get to. So, due on Monday is section 10.2 homework number 60, but any problem that says tangents, don't even try unless you're like, nah, I can learn it from the book. Cool, but you have my permission to skip anything to do with tangent line. That's at the very end of homework. Sound good? Yes. So 10.2, fully attempt everything up until the tangent lines. Fully attempt everything up until the tangent lines, because we're just going to cover tangents and then 10.3.